So, good day ma'am, good day everyone. This is my pre-calculus, my quiz number 2, and also my performance task number 1. So, first, let us know the topic that is consists. So, test 1, it consists graphing sine and cosine. Then test 2, this is simplifying trigonometric expression. And then test 3 is the simplifying trigonometric expression. So, let's first the test 1, number 1. So we have y is equal to 3 sine of 2x plus 90 degrees minus 2. So first, let us first identify the value of a, b, c, and d. In determining the value of a, b, and c, we're going to look at the numbers beside the sine, x, and also beyond that. So first, let the value of x, the value of a. The value of a is the number before the word sine or any other trigonometric function. So first, the value of a is the one that is beside the sine, that is 3. So we have a 3. So the value of a is 3. Next is the value of b. The value of b is a number beside the variable x. So what is that? That is 2. So we have the value of b, which is 2. And then next, the value of c. C is the number inside the trigonometric function. So that is here. The one who's in degree or sometimes in radian form. Then the sign of it will going to be opposite. If the number is positive, the value of c is negative. So in here we have this case that we have a positive value, so it will become negative, so our value will become negative 90 degrees. So last, the value of t, that is the constant value, so we have negative 2. So in here we're going to get the also negative. What sign of it is also the sign of it, so we have d is equal to negative 2. After getting the value of a, b, and c, we're going to proceed to number 2 step. We are getting the properties of the trigonometric function. So first, we have the amplitude. The amplitude is equal to absolute value of a, wherein our a is equal to 3, so absolute value of 3 is equal to 3. Next is the period, wherein the formula is 2 pi over b, wherein our b is equal to 2, therefore we have 2 pi over 2. And then, by simplifying 2, canceling 2 and numerator and denominator, we could get pi or equals to 180 degree in degree. So we have next the h shape or the horizontal shape, which is the formula c over b. So we have c equals to negative degree, and we have b is equal to 2. So we have negative 90 over 2, and by simplifying it, we have negative 45 degree, or in radian, we have negative pi over 4. And next, the vertical shape or the b shape is also simply equals to the value of d, wherein we have the value of d is equal to negative 2. And after we having these properties, next proceed to determining the intervals or the one period of the graph. So first, finding the each endpoint of the period. That is somewhere like here. In finding the period, we have the 4 intervals. So we have 1, 2, 3, and 4. May line dito but nawala. Somewhere like that. So finding the endpoint of the period. So first, finding the right endpoint is equal to period plus the horizontal shape. So what is the right endpoint? This one. Somewhere like, yeah, this one. And then the formula for that is period plus horizontal shape. So what is our period? Our period that we get is pi minus 45 degree, and that is our, and negative 45 degrees our h shape. So negative pi plus negative 45 degree is the same as pi minus 45 degree. And then we're going to transform pi is equal into degree, which is equal to 180 degree minus 45 degree, which is equal to 135 degrees. So let's try the other way. Let's try to make 45 degree into radians. So it will become pi over 4. And then we're going to get the common denominator. We have 4 pi over 4 minus pi over 4. And by simply combining it, we have 4 pi minus pi is equal to 3 pi over 4. And that's it. We have the right endpoint. That's somewhere like here. And then next is the left endpoint, this one. That is the formula for that is 0 plus the horizontal shift. Our horizontal shift is negative 45, so we have 0 minus 45 degrees. So any number the minus or add to 0 is still the number you add to it. So we have negative 45 degree, and we're going to put here in the number line we have negative pi over 4. If we were going to put that in the number line, we're going to get the radians form, this one, to make it easy to put there. So first, let's put the right endpoint. We have 3 pi over 4, and then the left endpoint we have pi over 4, and then the next thing we will get is the middle one. The middle one is the easier to get. So to get that, we're going to add this one. Negative pi over 4 plus 3 pi over 4 will be equal to negative 2 pi, which is equal to 2 pi over 4, which is also equal to pi over 4. And then next, we will going to divide it to 2. So the answer is pi over 2, and then we're going to divide that to 2. We'll get pi over 4. The next thing to do is to this one, or either to this one, to both 2 you can get. So I choose this one. So plus negative pi over 4 plus pi over 4 will get 0. So 0 over 2 and divided to 2 will get 0. And then next is this one. So going to 8 pi over 4 plus 3 pi over 4, we get 4 pi over 4, or simply pi, and divided to 2 we have pi over 2. And then we have now the number line. So as you can see, we have negative number and then positive number, and we have 0. If we're going to give a conclusion to that, we will get that the negative number will be in the left side and the positive number will be in the right side. And we have 0 here, so it means that is the y-axis or the origin. Now the next thing we do is getting the sign value, table of values. So we have this number line right here. We're going to put the values in the x-axis somewhere in here, the boxes. So first we have negative pi over 4, 0, pi over 4, and pi over 2, and also 3 pi over 4. So the next thing we're going to do is find the sine x, or the value of y, in this equation to graph the equation that we need. So the thing that we need to do is to substitute the value of x to the equation. We have the value of x there, pi over 4, negative pi over 4. So we're going to substitute here, and the result will be this one. So we have 3 sine of 2 times negative pi over 4 plus 90 degree quantity minus 2. So the next thing we do is transform the radian into degree. So it will become negative 45 degrees. And then with simplifying it, we have 2 times negative 45, we have negative 90 degree. And then next, combining negative 90 plus 90 degree, we have 0. So we have 3 sine 0 minus 2. And then the performing sine 0, we have 0. And then 3 times 0, we have 0 minus 2. And that will give us y is equal to 2. Next one, we have the value of x, which is 0. By substituting that in the equation, we will get this one. Y is equal to 3 sine of 2 times 0 plus 90. So 2 times 0 will also become 0. So 3 sine 0 plus 90 degree will minus 2 will give us 3 sine 90 degree minus 2. Well, the sine 90 is equal to 1. So we have 3 times 1, is equal to 3. So 3 minus 2 will give us 1. So y is equal to 1. And by getting the other coordinates, the value of x, just substituting simply that, and you get so on and so forth. Calculating that is very mahaba. So, di na natin siya isasama. Then, we have negative 2, negative 5, and negative 2 for our table of values. The next thing we do is going to graph the coordinates that we get. So, we first create a Cartesian plane and then put the values in the x-axis and also put the values in the y-axis, which is 1, 2, 3, 4, negative 1, 2, negative 2, negative 3, and so on and so forth. So we have the value of negative pi over 4 and negative 2. So negative pi over 4 is here, and then the negative 2 is here, so somewhere like here is the point. And then next is the 0, comma 1. So we have 0 here, the value of x, and then akyat tayo ng isa. So we have there. And the next is pi 4 and negative 2. Here yon. Then we're going to go down, negative 2. Then we have the point. Then pi over 2 and negative 5. So we have going to go down. So we have that point. And then 3 pi over 4 minus 2, negative 2 is somewhere like here. Alright, so we have the point. Now we're going to create a smooth curve. So here we go. There. That is the graph of one period of the function y is equal to 3 sine 2x plus 90 degree minus 4. And if going to graph that in a graphing calculator, we get this one for perfect graph. As you can see, they are also the same. And then next is going to get the domain in range. So the domain of a trigonometric function is always x is a set of real number, because it continuously going with the flow in the x-axis. And then next is the range, which is here, the lowest and the highest point. In here we have the lowest point, which is negative 5, and the highest point, which is 1. So getting that is going to use bracket because it is included in the solution. And we're going to first the negative sign because it is smaller, and negative 1 at the end. And the next, we're going to extend the graph that we have made into one period at each point. So as you can see, the graph is identical. It's also the same amplitude here, yes, same range and domain. There we go. The next one, we have test 1 number 2. We have y is equal to 2 cosine of 4x minus 120 degree plus 3. So first, also we're going to get value of a, b, c, and d. And getting that, again, we're going to look at the coefficient of each term. So here, the value of a is the number beside the trigonometric sign. So in here, that is that number 2. We have a is equal to 2. And now next is the value of b. The value of b is the number beside the variable x. So what is that? That is 4. So 4 now is the value of b. And the next is the value of c. Again, when we're getting the value of c, that is somewhere beside here, the degree or the radians. The value, the constant value belong inside the trigonometric function. And again, if the sign of the degree number in here is negative or positive, we're going to get the opposite of that. So we have negative 120 degree, so we could get positive 120 degree because it is negative. Then last is the value of the constant term. We have number 3. So yeah, going to get that 3. If that's positive, then negative, right? Positive 3. And then next, we're going to get the amplitude and the other properties. So first, the amplitude. Amplitude is equal to absolute value of A, wherein our value of A is equal to 2. The absolute value of 2 is 2. And then next is the period. We have 2 pi over B. The value of our B is 4. Therefore, we have 2 pi over 4. And simplify it, we could get pi over 2. Or simply 90 degree in degrees. And then next is the horizontal shift, wherein our value of C is 120 degree and the value of B is 4. So if we're going to write that, 120 over 4. And by simplifying it, we have 30 degrees or pi over 6. The next thing is the vertical shift. We have the value, it is equal to value of D, wherein our D is equal to 3. The next thing we're going to do is going to get the interval or the number of one period. So finding the each endpoint of the period. So in one period we have each endpoints. So first we'll get the right endpoint, this one. So that is equal to period plus horizontal shift. So we have the period of pi over 2, then we have the horizontal shift which is pi over 6. We're going always to use the radian because it is easier to graph in a calculator. Then next is we're going to get the common denominator. So we will get 3 pi over 6 plus pi over 6. And then by combining the terms, we have 3 pi plus pi, we will get 4 pi over 6. Or by simplifying it, we will get 2 pi over 3. And then next is the left endpoint, this one. So 0 plus horizontal shift, that is the formula to use the find the endpoint. This way is easier than graphing the each shift, which makes you longer time to take when taking a activity like this. So this formula that I created is much easier. So we have the 0 plus the horizontal shift, which is pi over 6. So if any number combined to 0 is always the same as the number. So in plotting that, we could get the right endpoint here. So we'll be put it here. So we have that, and then this one at this end. So next one is getting this one, the middle one. In getting that, we're going to add this one and then divided by 2, and that is called the average to get the middle number. So pi over 6 plus 2 pi over 3 is equal to 5 pi over 12 divided by 2, and we get this. And then by getting this, we're going to add this, and then divided by 2, and we'll get this 7 pi over 24. And to get this one, we're going to this one add, and then divided by 2, and then get this one 13 pi over 2. Now we have the number line, and as you can see, all the number that we get is positive. Therefore, all of that will be found in the right side of x-axis. There we go. And then next, we're going to create the table of values. So in creating table of values, we create x and cosine over x. So in the value of x's, we got this and put it here. So we have pi over 6, 7 pi over 24, 5 pi over 12, and 13 pi over 24, and last 2 pi over 3. And after that, as the same as we done in the number 1, we're going to substitute this number, the value of x, to here. So if that, here is it. So y is equal to cosine 4x minus 2 pi plus 3. If substitute the value of x, which is pi over 6, we will get this one. 2 cosine of 4 times pi over 6 minus 120 degree plus 3. And after that, we're going to create this one into degree form. So we have 30 degree. So 4 times 30 will get 120. So 120 minus 120, we will get 0. That's the cosine of 0 is equal to 1. So we have 2 times 1 is equal to 2. So 2 plus 3 is equal to 5. So we have the value of y is equal to 5. And the next one is this. Substitute that here. We have this one, 7 pi over 4, and substituting the x. So that by creating this into degree, we have 52.5 degree. After that, we multiplied it by 4, we could get 210. And then 210 minus 120, we have 90 degree. And the cosine 90 degree is equal to 0. And 0 plus 3 is equal to 3. We have y is equal to 3. And then the next one, this one. So 5 pi over 12, substitute it here. And we have this. And transforming it into degree, we have 75 degree. And 4 times 75 degree is equal to 300. 300 minus 120 degree is equal to 180 degree. And the cosine of 180 degree is equal to negative 1. And negative 1 times 2, we have negative 2 plus 3. And that is equal to y is equal to 1. So we have y is equal to 1. And to get the other remaining values of x's, just simply substitute it here. And you can get 3 and 5. And we have now the table of values. The next thing we do is to graph. So we have created Cartesian plane, created numbers. So we have the values of x's and put it here. So we have negative 7 pi over 4, negative pi over 6, pi over 6, 7 of pi over 24, pi over 12, and 13 pi over 24, and last 2 pi over 3. So I know you are thinking why these numbers are here, but that is not here. So that we all know that Cartesian plane has the same number in both sides. So as you can see, we have same distances here. So it means that it's also the value of it, but in negative form. And also this one and this one. So we can put it many number that it is here. So next is plotting the coordinates. So we have pi over 6 comma 5. So we have pi over 6, this one, 1 2 3 4 and 5 we have here. And then next is 7 pi over 9 3. So here 3 here. So this one naman is in 1, this one, and then here, and then this one 2 pi over 3 is nasa comma 5. So we have here. And creating a smooth graph, we have this one. So as you can see, if we are going to graph a one period of a cosine, is like look a parabola. So if we're going to graph it in graphing calculator, we could get this, and we name it y is equal to 2x quantity 4x minus 120 quantity plus 3. And then the domain of it, always that the domain of a trigonometric function is set of real number. And the next is the range, which is 1 up to 5. So we have this, the lowest point 1, and then the highest point 5, and that is included, so that's why we use bracket. Next, we're going to extend the graph one period in both sides. So we could get this one. As you can see, same amplitude and same characteristic of the graph, that is identical, and it is continuously. That's why our domain is a set of real number, because it continues at both sides of the graph. So now let's go to test number 2, number 1, which is simplifying the trigonometric expression. So we have cosine squared x quantity 1 plus tangent square x. In this, we will notice that 1 plus tangent square x looks familiar, right? We can see this in Pythagorean identity, wherein 1 plus tangent square x is equal to secant square x. And we by concluded that we're going to substitute secant square x in here, so we could get this one. So cosine square x times secant square x, because we substitute it. Then next we're going to do is the reciprocal identity, wherein the secant square x is also equal to 1 over cosine x, cosine square x rather. So we're going to this one. So we have cosine square x times 1 over cosine square x. So in here, what's going to do next? So next one is going to be like this. We're going to cancel cosine square x in the numerator and the denominator. So cancel that and also that. And we're going to get 1. And 1 will be our final answer in simplifying this expression. So 1 is the answer for this number. And then last number is test number 3, number 1. So we have tangent x over cosecant x plus 1 over secant x is equal to secant x. And this one is proving the trigonometric expression. So the first thing we're going to do is make all of this side, because this side is more complicated than here. We can make it 1 than this making it many. So first is making this all of this term in terms of cosine and sine to make it easier for us to create an number. So what happened? So what happened here is that we apply identity on each term. So you have tan x here. So tan x here is we have the quotient identity. And tan x is equal to sine over cosine x. And also next is the reciprocal identity. Reciprocal identity is done by this term, cosecant x and the secant x. So it will become cosecant x is equal to 1 over sine x, and the secant x is equal to cosine 1 over cosine x. This term. Yes, that is the reciprocal identity. The next one happen is we get the reciprocal. Simplifying it, we divide 1 over x in here, so we get the reciprocal of it, which is sine over sine x. Simplify reciprocal of 1 over sine x. And then reciprocal of 1 over cosine x is cosine, and cosine times 1 we get cosine x. And then we have this equation, sine x over cosine x multiplied by sine x plus cosine x is equal to secant x. Don't remove this one, because if you remove that, that's very important thing in the equation. So next thing we do, we simplify. So we combine this sine and this sine, we multiply that, we get sine x square. So after that, we're going to have this one. So what will happen? So the thing that happened is cosine x is cross multiplied to here to get the common denominator. To get the common denominator, we have 1 here, so easy to get that is cross multiply. So cosine x times cosine x will get us cosine x square, and because we multiply that, that is become the numerator of this. So we have cosine x as denominator. So x square plus x cosine x square is equal over cosine x is equal to secant x. So next, as we can see here, this expression, this sine square plus cosine square is a Pythagorean identity, and that is equal to 1. That is always equal to 1 because of the Pythagorean identity. And that is, here we go, 1 over cosine x is our answer. And then next, what will happen? So this term, we're going to get the reciprocal identity niya. So the reciprocal identity of 1 over cosine x is secant x. And now we have secant x is equal to secant x, proven by reciprocal identity. So we are now prove that secant x is equal to secant x. And that's all. Thank you very much for listening. That's my quiz. I hope that is correct and perfect. Thank you very much.